Hey everyone, this is Dr. Walker. This is video 231. It's called Ohm's Law. This video we're going to put together things that we have learned about voltage, current, and resistance. We're going to put it all together into Ohm's Law. So the first question is, how is this possible? You've probably seen birds perching on high voltage power lines and they don't get fried up or anything. They're perfectly fine. Why do you think that is? Definitely put your thoughts in the comments below. So the first question to begin this video is, a battery is connected to a resistor. What happens when you increase the resistance of the resistor? And we've actually talked about this in a previous video, so this is just a warm-up. So just use your instinct here. If you have more resistance, that means that you have more impedance of the flow of charge. You're preventing the charges from flowing to have less current in the circuits when you increase the resistance. Ohm's law is provided here. It says I equals delta V over R. Current is proportional to potential difference and inversely proportional to resistance. This little triangle is just a visual for some people. They appreciate it. So you can rewrite Ohm's law different ways, right? You could solve for delta V to get I times R, or you could solve for R to get delta V over I. So what this triangle does, it shows you all the different combinations. So if you've got I, it's V over R, you can see. If you have V, it's I times R, they're next to each other, multiplied. And if you have R, it's V divided by I. Just a little visual here. And then we have another visual that I enjoy. This picture here that shows that the voltage is what's giving the charge the energy to move. So the charge is moving is the current, which is the amps, and then the ohm is the resistance that's trying to impede the flow of that charge. I thought that was a pretty cute drawing. Let's take a look at this applet real quick just for another visual. So this is a fat applet called Ohm's law, and you can just change the parameters and see how they affect how the voltage and the resistance affect the current. So as we increase the voltage, we can see that the current gets bigger. You can see the little I here gets bigger and bigger as you increase the voltage. The arrow also gets bigger. What we also see as we increase the voltage is we see that there's more and more batteries put together, so giving us an indication that adding more batteries together does increase the voltage as well. And then the resistance, as we increase the resistance, we can see that the current gets even smaller. When we decrease the resistance, the current gets bigger when R gets smaller. And we can also see in this visual, just like in the other visual in the previous video, that when you increase the resistance, you can see that there's just more stuff, more impurities in this resistor that is resisting the flow of the current. So let's take a look at this one question. This is, again, more of an example, but since it was a quick plug and chug, I just decided to make it into a your turn. So it says the glowing element in an incandescent light bulb is a filament, a long thin piece of tungsten wire that is heated by the electric current through it. When connected to 120 volts of an electric outlet, a 60-watt bulb carries a current of 0.5 amps. What's the resistance of the filament in the lamp? This is a simple application of Ohm's law, so please try it on your own. Pause the video for a second. You'll notice that the 60 watt here, that's the power, that's actually extra information. We don't need it for this problem. We can just use Ohm's law that says I equals delta V over R, and just solve for resistance, you get delta V over I. So the voltage is 120 volts, and the current is 0.5 amps. So the resistance is 120 divided by 0.5, which is equal to 240 ohms. That's it for this video. See you in the next one.